Conservation of Energy by Matthew.
Brendan.
Dave.
The law of conservation of energy applies not only to straight line motion, but rotational motion as well.
In this video, we will find both the translational and rotational velocities of the snowball.
Here are a few components we will need to find both speeds.
These include the gravity, the height of the hill, the mass of the snowball, and the radius of the snowball.
The two types of mechanical energy that we are using are gravitational potential energy and kinetic energy.
According to the law of conservation of energy, the combined potential and kinetic energy will be the same at any point of the ball's trip.
Since the ball has all the potential energy at the beginning and all the kinetic energy at the end, we can set the equations for initial potential energy and final kinetic energy equal. The equation for gravitational potential energy is mass times gravity times height.
The equation for translational kinetic energy is half mass times velocity squared, and the equation for rotational kinetic energy is half inertia times omega squared.
Because the snowball is a solid sphere, inertia has to equal 2/5 mass radius squared.
We then simplified the equation for omega and retrieved an answer of 17.55 radians per second.
To find tangential velocity, we used the same equation we used to find omega, but simplified it in a different manner.
Instead of substituting the translational velocity for omega times the radius, we substituted omega for Vt divided by the radius.
When we solved for Vt, or tangential velocity, we got an answer of 8.78 meters per second.
Spider-Man does whatever a spider can. Spins a web any size, catches thieves just like flies. Look out, here comes the Spider-Man.